Hello everyone. So in this video, we will solve this set of problems. At the beginning of every problem, you will see the full question with a 3-second timer like this. I urge you, I beg you to pause the video when you see the timer and try to solve the problem yourself first. This will really help you become more independent and better at problem solving. There is another important reason. If you solve the problem independently, it will really expand your thinking. And sometimes you will witness that your solution is better, smarter than mine. And those will be proud moments indeed. Alright, let's get started then. Remember to pause the video when you see the timer. Which of the following solid shapes can be made with these 6 bricks? Alright, we have 1, 2 white bricks, 1, 2, 3, 4 gray bricks. Let's keep that in mind. So we can just count the total number of white and gray bricks. We can count either one, white or gray. Let's stick with white. So for choice A, I have 1, 2, 3 white bricks, but here I have only 2, so A cannot be the correct choice. Similarly, you can count the number of white bricks in other options. I can see that in choice D, I have 1, 2 white bricks, and then I have 1, 2, 3, and 4 gray bricks. That's exactly what I need. Then D is the correct choice. In how many places in the picture are 2 children holding each other with their left hands, right? So let me draw the picture of one child. So this child is looking into the screen. So if I'm looking into the screen, this is my right, this is my left. So this is right, this is left, right? Let me draw the picture of another child who is looking away from the screen, right? So in this case, this is left, this is right. So this is left, this is right. Now accordingly, let's mark the left and right hands of each of the child here. So she is looking into, so this is going to be right, left, similarly right, left. He is looking into, so this is right, left. All right. For the child who is looking out of the screen, this is going to be left, right, left, right, left, right, left, right. Now from here, we can clearly see that only in one places they are holding with their left hands. Then A is the correct choice. One thing to realize here is that when 2 persons are looking in the opposite directions, they will be holding each other either with left or right. But when they are looking in the same directions, it will be left and right. Okay, so let me just draw another person here who is looking out of the screen. Right and left, so this will be right and left. So as you can see here, when they are standing next to each other, and if they are looking in the opposite direction, it is going to be either left or right. So in this case, we basically need to figure out in how many places they are looking in the opposite direction, and then see which of that is going to be left. Here you can see that this is one place they are looking in the opposite direction. This is another place they are looking in the opposite direction, and this is another place, right? And out of these 3, only one happens to be left, like this. In the square, you can see the digits from 1 to 9. A number is created by starting at the star, following the line and writing down the digits along the line while passing. For example, the line shown represents the number this. Which of the following lines represent the largest number? Okay, so let's check the example. 4, 2, 6, 8, 5. So 4, 2, 6, 8, 5. So as you can see, 4, 2, 6, 8, 5 is represented by this. Okay, and then we need to figure out which of these represents the largest digit. One thing to note is that all these are 5-digit numbers, right? So they have 5 digits. 1, 2, 3, 4, 5. So they are all 5-digit numbers. Now we want to first check the leftmost digit, right? And the one that has the largest leftmost digit will be the largest number. But if the leftmost is the same, then we need to check the next digit, and so on and so forth. Okay. So so let me erase this. The digits are increasing left to right and then top to bottom. So note that we want to start at the largest digit, and that is 9, right? So I can see that only B and E, they start at the largest digit of 9. So then clearly the other options are not going to work. Okay, so we can rule out the other options based on that. So between B and E, so B is going from 9 to 8. So let me write down B here, and then I will write down E here. So both start. Okay, let me first write down B. 9, 9, then goes this way 8, and then goes straight up. This is 5, right? Okay, I can see that in the third place they already changed the direction. So let me start writing E. E starts at 9 2, and then goes to 8, and then goes to 6, right? So from here I can see that E is the largest number. Sofie wants to write the word KENGU by using the letters from the boxes. She can only take one letter from each box. What letter must Sofie take from box 4? Alright, so we can see that box 3 has only one letter, so we must take that letter from box 3. So the N from box 3, so C is gone. Alright, so next let's look at box 1. N combines with E, N is already gone, so E must go from box 1. That means E is also gone, right? Okay, next N and E are gone. Okay, E is gone, right? So U must go from box 5, right? U must go from box 5. Okay, so E and U are gone. Now if we carefully look now, E is gone, U is gone, N is gone, right? Then only remaining is G here, box 4. So that must go from box 4. That means D is the correct choice. When the 5 pieces are fitted together correctly, the result is a rectangle with a calculation written on it. What is the answer to this calculation? Alright, so let me first make the rectangle and make room for the 5 pieces. 2. So this is the rectangle. First thing to note is that whatever piece goes here must have the left edge flat, right? Then one has that left edge flat, so one must go here. So one is done. All right. Similarly, whichever piece goes here at the end must have the right edge flat, and 0 has that right edge flat. So then 0 must go there. All right. Now, okay, let me draw this here. So the puzzle piece 1 has a little hole there, so that I can fit the puzzle pieces correctly, and the 0 also has this little hole there. Okay, now I have 3 more pieces, 2, 2 and plus. Okay, I can try one at a time actually. So there is a hole here, so 2 can go there, so these 2 can go there, so these 2 can go there, right? This has a tip and it has a hole on the other side, right? Or plus can go there, right? Plus can also go there. But the plus has a tip here and a tip here. These two cannot go here, right? These two cannot go here because this two has a hole. It needs to have this tip, all right? Now, if I put this two here, right, I need something with a tip, right? So then plus can go here. This is a tip and this is a tip, right? And the plus already has a tip, so that this two can go there, right? So these two can go there. So this two has this hole, and on the other side it has the tip, right? All right. So what I'm left with here is, so in this case I have already used of this two and the plus sign. So is this two going to fit there? Let me check. If I put this two here, this has a hole and a tip, right? So this fits correctly here. But if I go this way, there is a plus sign. I have used, which two is this? So this two is this one, right? Now let me see if I can fit the other two. So other two has this pointy thingy here, and then so the other two has a pointy thingy here and the hole here, and clearly this does not match, right? So the correct way of fitting is 1 2 plus 2 0. So this is going to be 12 plus 20 is 32, and then B is the correct choice. A measuring tape is wound around a cylinder. What number should be placed shown by the question mark? All right, so this is the question mark. So what number should go there? So basically, if I can figure out how long it is to go one time around the cylinder, I'm all set, right? And how can I figure that out? I have some data given here. For example, if I start at 6 and if I go one time around, I end up at 27. So how long that would be? So that will be 27 minus 6 will be 21. Okay. And this should work at any point. Let's say if I start at 8, if I end up at 29, so this is 29 minus 8 is 21. So you can start at any point, right? And if you go one time around, it is 21. All right. So then if I start at 27, if I go one time around, I'll end up here. And to go one time around, it is 21. So I will end up at 48, right? But I need to go one more time around, right, to reach at the question mark. So there is another 21. This is 9, 6, 69. Then C is the correct choice. The 5 figures on the grid can only move in the directions indicated by the black arrows. All right, so these are the only permitted directions. I can go sidewise or up and down. Okay, which figure can leave through gate G? Which figure can leave, right? So let's take a look at gate G. If I look here, the gate G is 3 units wide, right? So any of the figures that is 3 units wide or less can go through gate G. All right, so let's take one at a time. A, on the top level it is 1 unit wide, so which is fine, it can go through it. But in the second it is 1, 2 and 3, that is fine too. Third level 1, 2, 3, 4. 4 is not going to fit through gate G, right? So A is not going to work. Let's take B. 1, 2, 3. That is fine. 1, 2, 3. That is fine too. And then remember that the sidewise I can move, right? So once the 2 levels are out, I can always move the structure this way, right? This way, right? And then the next level will be 1, 2, and 3. So at all the levels, it is 3 units wide. So looks like B can work. Let's check C. C has 1, 2, 3, 4. So it has 4 units wide. That cannot fit through gate G. So C is not going to work. Remember, I cannot flip. That is not allowed. That is not one of the allowed moves, right? So I cannot flip, right? D. At the top it is 1 unit, which is fine. Here it is 1, 2, 3 unit. That is fine too. Here it is 1, 2, 3, 4. 4 is not going to fit. So D will not work. E. At the top level 1 unit, that is fine. 1, 2, 3. That is fine too. Here it is 1, 2, 3, 4, 5. 5 is not going to pass through gate G. So E is not going to work. Then B is the correct choice. Carin is going to paint the walls in her room green. The green paint is too dark, so she mixes it with white paint. She tries different mixtures. Which of the following mixtures will give the darkest green color? We want darkest green. Let's say we have G parts green, G for green, and W parts white, W for white. Then we want the fraction G over G plus W. So this is green and this is total, right? So we want this fraction to be the highest. That's how we get the darkest shade of green, right? So for A, there is 1 part green and 3 part white. So there is 1 plus 3 total. So this leads me to 1 over 4. For B, 2 parts green, right? And then out of total 2 plus 6. So this gives me 2 over 8, which is 1 over 4. If I can simplify, this is 4, right? Okay. For C, 3 parts green out of total 3 plus 9. 3 plus 9. So this is going to be 3 over 12. Again, this is going to be 1 over 4, right? Let's check the D. D is going to be 4 parts green out of total 4 plus 12. 4 green, 12 white. So this is 4 over 16. This is again 1 over 4. So as you can see, in each case, we end up with 1 over 4, right? So they will all be equally dark. E is the correct choice. Mary had a piece of paper. She folded it exactly in half. Then she folded it exactly in half again. She got this shape. Which of the shapes P, Q, or R could have been the shape of her original piece of paper? So she folded twice, like every time in half, right? Okay, so let me try to fold it here and see if I can get to this shape. Here, I can fold it in half like this. Let's say I fold it like this, so I'm just going to take it out. And then what I'll do is I'm going to fold it like this. So this goes over that, right? So I can, as you can see, I can get this shape, right? It's a right angle triangle, right? Okay. Now for Q, let me fold like this, right? I fold one on top of other. So this folds on top of that. And then what I'm going to do is fold it like this. So again, so this is going to be a right angle, right? This is also going to result in that shape. For this one, let me fold it like this, right? So I'm going to fold this on top, and then I'm going to fold it like this, and again I will end up with that shape. So in all cases I will end up with that shape. Then it is any of PQ. Okay, so this R should go here, any of PQ or R, and E is the correct choice. There is a square with line segments drawn inside it. The line segments are drawn either from the vertices or the midpoints of other line segments. Okay, either from vertices or midpoints. We color, all right, this should be 1/8, right, of the large square. Which one is our coloring? So we color 1/8 of the large square. So 1/8 is basically half of half of half, right? That's how we get 1/8. All right, so I can start doing half of half of half and see if I can end up with the same area as the color. So let me first do half here. Okay, so I will keep the side where the color is there, right? So this is 1 time half, this is a 2 times half, and this is a 3 times half. So I will keep this area, but as you can see, the red area, right, is less than 1/8. So A is not going to work. Let's try B. I'll do half here, right, and I'll keep this part, and do another half, and I'll keep this part here, and do another half, right? Again, we can see that the blue is less than 1/8, right? So B is also not going to work. C. So I'll do 1 half here, right? Second half here, and then the third half here. So I needed this, but the yellow area is more than that. Again, so C is not going to work, right? Let's D. I'll do 1 half here, another half here, and the third time here. All right, so the green area matches with what I need, 1/8, right? The D seems like a good choice. We can just double check E. So I'll do half here, second time, third time. So I needed only this much, but the orange area is more than that. So E is also not going to work. Then D is the correct choice. So for this problem, I can also calculate the actual area and find out. So let me do that. Let me assume the square is 1 unit by 1 unit. It is a square. Then what is the size of the small red square there? I know that this is going to be half. If the whole thing is 1, then that is half, because we always take the midpoints. Then this is half of that, so that is going to be 1/4. And then this is half of that, so this is going to be 1/8, right? So the area of the red square is, it is a square, so it's a base time height. Base is 1/8 times height is 1/8. So this is 1/64, right? All right, let me calculate the area here. I know that this is half, so this is half of that, so this is going to be 1/4, and this is half, right? So area of the triangle is half times base. Base is 1/4 times height is half. So this is going to be 1/16, right? Let's do it for this. Here the base is half, so this is going to be half, right? This base is half, height is 1. So area of the triangle is half times base is half times height is 1. So this is going to be 1/4, right? All right, in this case, the base is half, height is also half, right? So area is going to be half times base, which is half, times height, which is also half. So this is going to be 1/8, right? For this case, this is a square, and this is half. This is also half. If we assume the whole thing to be 1, then this is half, and this is half. So area of the square is base, which is half, times height, which is also half. So this is 1/4. So in this case, we get 1/4, 1/8, 1/4, 1/16, and 1/64. But we want a 1/8. So again, D is the correct choice. The number is written on a sheet of paper. Julian cuts the sheet twice, so he gets 3 numbers. What is the smallest sum he can get by adding those 3 numbers? All right, so we want the sum to be the smallest possible. Now, for the sum to be smallest, we want the 3 numbers to be as small as possible. Then we can ensure that the sum is smallest. All right, so when I'm splitting this number, right, first condition that we need to keep in mind is the number of digits in the maximum number of digits in any of these 3 numbers should be as low as possible, right? So let me write it down, then explain. So first of all, the total number of digits is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of digits is 10. So the number of digits in number 1, number 2, number 3, because we are splitting it twice, so we are getting 3 numbers, right? So these, let's say these are the 3 numbers, and first I'm trying to figure out how many digits each of these numbers can have. So what I'm saying is the maximum number of digits any of this number has to be as low as possible, and the way to do that would be 3, 3 and 4, right? So 3 plus 3 is 6 plus 4 is 10, so we have total 10 digits. All right, so why is this why will this give the smallest numbers? Because let's say, just for the sake of explaining, this has only 2 digits, right? And this has 3. Then to make up total 10, this will have 5 digits, right? Now remember, even the smallest 5-digit number is going to be larger than the biggest 4-digit number, right? So any other way we split, right, the numbers, one of the numbers is going to be larger than we need, right? So we cannot have it this way. So this is the correct way to split 3, 3 and 4, so that we want to make sure that the maximum number of digits any of these numbers have, in this case 4, is as low as possible, right? There's no other way we can split to make this maximum number as low as possible. All right, so let's keep that in mind. So we want to split it in 3, 3 and 4. Okay, so let me actually write that down. Let's remember this. I have to erase this because I need to write the number. So we want our digits to be 3, 3 and 4 to give us total 10-digit number, right? So let me write down this number. 5, 0, 2, 1, 9, 7, 2, 9, 7, 0. All right. So we want to split it in 3, 3 and 4. Okay. So this is one end, this is the other end. So let me first cut it like this: 3, another 3, and then 4. So this is one way I can cut, right? The other way I can cut is, 3, and then 4 here, and then 3, right? The other way I can cut is, 4 here, and then 3 here, and then 3 here, right? So I have roughly aligned it where I'm cutting, right? Okay. Now think about it. Wherever we have the 4-digit number, right? So in this case, this is the 4-digit number. In this case, this is the 4-digit number. In this case, this is the 4-digit number. For the 4-digit number, we want the leftmost digit to be as low as possible. We don't want it to be a higher number, right? Now, in all these 3 cases, this is a 4-digit, this is another option 4-digit, this is another option 4-digit, right? In all these 3 cases, we can see that, this case, we'll have 1 as the leftmost digit and the number will be the smallest, because 1972 is smaller than 5021, right? So if I have this as a 4-digit number, 5 will be at the leftmost digit, and this is definitely going to be more than if I had 1 as the leftmost digit, right? So this has to be the 4-digit number, right? Then we are left with this to be 3-digit number and this to be the other 3-digit number, right? So then, so let me write down here 1972, 1972. So that should be my 4-digit number. this should be my 4-digit number, right? And then 502, so this is going to be 4, 7, 4, 2, and then this is the other 3-digit number, 970, this will be 4, 4, 4, 3, right? Now, this is the sum of the 3 numbers such that, I get the smallest sum. Then B is the correct choice. Think about it a little bit more. Why I am doing it the way I did it, like how I am splitting, why I am splitting it into 3, 3 and 4 digits and not any other way. And then once I have decided 3, 3 and 4 digits, then how I am, how I am choosing where to cut, right? How I am choosing where to cut, because we want to cut it such that, the 4-digit number, I end up with the lowest number for the leftmost digit. All right. Okay. One more thing. How did I come up with this grouping of 3, 3 and 4? Right. So I had total of 10 digits. Remember, I had total of 10 digits. I wanted to divide it into 3 groups. Right. Then I'll get a 3 and remainder of 1. Right. So when I divide 10 with 3, I get 3 whole and a remainder of 1, right? So there will be 3 groups of 3 each, and then I give whatever is remaining, I distribute whatever is remaining among as many groups as I can. In this case, I have only 1 remaining, so I'll just give it to 1. So this will be 3, this will be 3, and this will be 4. So this is how I came up with the grouping of 3, 3 and 4. 3, 3 and 4. The map shows 3 bus stations at point A, B and C. A tour from station A to the zoo and the port and back to A is 10 km long. So basically A to zoo to port and back to A is 10 km long. A tour from station B to the park. Basically, inside each triangle there is a number written that tells me how long to go around that triangle one time, right? So I'll skip reading the rest. Let's read what we want. How long is the shortest route from A to B to C and back to A, right? So how long it is to go from A to B to C and back to A, the shortest distance. The shortest distance is basically going to be the outer perimeter of this curved triangle, right? Any other path you choose is going to be longer than that. All right. So notice that, let me try to go, around each triangle one time and see which sides I am adding up. Right? For example, if I go from A to zoo to port, I add this side once, and this side once, right? So I'm marking one line if I travel that path one time, right? Similarly, if I go, so that is this number. So similarly, the 12 is basically going here, here, and here. And 13 is going here, here, and here. Okay. So if I add up all these, that will be 10 plus 12 plus 13. But what I want is add only the outer sides, right? That means I have to take out the length of the inner sides, right? But the inner sides, as you know, is 15. That's given to us, right? 15 is basically going one time here, and one time here. So basically the shortest tour from A to B to C is going to be add up 10 plus 12 plus 13 and then subtract the 15. So 10 plus 12 plus 13, right? Minus 15, right? Because 10 is going along each path once, 12 is going along each path of this triangle once, 13 is going along each path of this triangle once, but that also includes the inside paths. So I want to take it out, right? So this is basically going to be, this is 13. If I borrow 2 here is 15, so that will cancel out, and then this is going to be 20, right? Then B is the correct choice. You can also do this in a little bit more formal algebra way. So let me name each sides. Let me call it A, B, C, D, E, F. This is G, H, I. All right. So what is given to us is A plus F plus G is 10, right? A plus F plus G is 10. Similarly, B, C and H, B plus C plus H is 12. Similarly, D, E, I, D plus E plus I is equal to 13, right? And H, I plus G, H plus I plus G, that is given to us is 15. What we want is A plus B plus C plus D plus E plus F. So we want A plus B plus C plus D plus E plus F. All right. So now if you look at this equations, right? If you look at this 4 equations, I have A, B, C, D, E, F, right? So I have A, B, C, D, E, F, right? That is what I want. Plus I have extra of G, H, I. So that is G, H, I is here. So I want to add these 3 equations. This equation plus this equation plus this equation. And then I want to subtract this equation, right? So I want to subtract this equation. So that essentially is the same as what we did earlier. So H, I and G, H, I and G will cancel out. Only thing that will be remaining on the left hand side is, A, B, C, D, E, F, A, B, C, D, E, F, what we want. And on the right hand side, it will be, 10 plus 12 plus 13 minus 15. Remember, we are adding these 3 and subtracting this. So this is exactly what we did before, and this is basically 20, right? Same answer. Rosa wants to start at the arrow, start here, and follow the line and get out at the other arrow and get out here. Which piece is not possible to put in the middle to obtain that? All right. So we want to start here. Okay. So this is where we get stuck. And then if we trace the exit, all right. So somehow we have to connect this to this. All right. So let me change the color. One way I can see, looking at this, just scanning through these shapes, one connection can be like that, and the other connection can be like this, right? Then you can go and come back. All right. Now let's take a look. For this connection, I can see that I can do that here. This is the same. So this is, we can get out with this. So this is not the correct choice. Similarly, I see that shape here. I can also use that. So then this is not going to be the correct choice. Next, let me look at the other one, other possibility. Now for this, connecting straight, I can see that I can do that with this, right? This. So this is also not going to be the correct choice. I can also do it here, right? So this is not also going to be the correct choice. Then the only thing that is remaining is D. Then D is the correct choice. Now in multiple choice questions, you are absolutely sure that the other choices do not work. Then the remaining one has to be correct, right? But in this case, let's actually try to draw it out and see, just to be sure that this is the correct answer. Let me erase it. All right. So I'm going like this. So this, let me change the color. This will join like this. This one is going to join me here, and then I go like this, and then from here, so as you can see, this is not going to lead us anywhere. It will go like this and here. We will not come out of that, right? So again, then D is the correct choice. The diagram shows 3 hexagons with numbers at their vertices, but some numbers are invisible. The sum of the 6 numbers around each hexagon is 30. Okay, what is the number on the vertex marked with a question mark? Alright, so what is the number here? Okay, some numbers are missing, but we are given the sum to be 30, right? So if the sum around this is 30 and we know these vertices, then we can figure out what is the sum of these two, right? So this is going to be 30 minus this, right? 30 minus 3 plus 6 plus 1 plus 2, right? So if the total is 30 and we know this much, right? 3, 6, 1, 2, we can subtract that and we get the sum of these two numbers. So this is going to be how much? 6 plus 3 is 9 plus 1 is 10 plus 2 is 12. So 30 minus 12 is 18. Alright. Similarly, what will be the sum of these two numbers? Again, that is going to be 30 minus, right? I'm taking this hexagon now, minus, 4 plus 6, 4, 6 plus 9 plus 4, right? And this is going to be 4 plus 6 is 10 plus 9 is 19 plus 4 is 23. 30 minus 23 is 7, right? Okay. Now we don't know this question mark, so let me call it x, right? Then x plus these two numbers, right, which is 18, plus these two numbers, which is 7, plus this is 1. This has to be also 30, right? That has to be 32. All right. So then from here I can easily see that 7 plus 1 is 8 plus 18 is 26. So this is 26. Then x is equal to 30 minus 26. Sorry, 26 is equal to 4. Right? Then D is the correct choice. 3 rectangles of the same height are positioned at stone. Alright, this is how. The numbers within the rectangles indicate their areas in centimeters square. Okay. If AB is equal to 6, how long is the distance CD? So we need to find out this distance. Given a rectangle with base B and height h, area equal to base times height. So if I know the area and if I know the base, I can find the height, or if I know the height, I can find the base, right? Okay, so let's first take a look at these two rectangles together. The total area is 12 plus 18 is 30. So I know the area and I know the base. Base is 6. So this height is then the area divided by the base. Base is 6. Base is, so is equal to 30 over 6 is equal to 5. So height, this is equal to 5. Okay. The next, let me change the color. Let's take a look at these two rectangles. Here the total area is 22 plus 18 is 40. right? Right. So we need to find out the base. Base is CD. So CD, so that is the base, is area divided by height. Area is 40 divided by height. We just found out, which is 5. So 40 over 5 is 8, right? Then C is the correct choice. You can also do this using algebra if you want to practice. Let me assume the height to be h and the base of the different rectangles to be A, B and C. Alright. So the area of the first rectangle, that is base times height, that is given 12. Similarly, for the second rectangle, B times h is equal to 18. For the third rectangle, C times h is equal to 22. So this is given to us. The three areas are given to us and we are expressing the area in terms of base and height. Alright, if we take these two equations, if you add it up together, it is AH plus BH is equal to 12 plus 18. Now if I apply the distributive property here, H times A plus B, 12 plus 18 is 30, right? But A plus B is 6, right? So H times 6 is equal to 30. So this tells me H is equal to 30 over 6 is equal to 5, right? This is what we also found out earlier. So H is equal to 5. Alright. Now, if I take these two equations, BH plus CH is equal to 18 plus 22. Again, I'll use the distributive property. H, B plus C. I take H common, then B plus C. 18 plus 22 is 40. But I know H is 5. H is 5. So B plus C is then 40 over 5 is equal to 8. Right? What is B plus C? B plus C is CD. That is what we are looking for, right? So we get the same answer, of course. C is the correct choice. A triangular pyramid is built with 10 identical balls, like this. Each ball has one of the letters A, B, C, D, and E on it. There are two balls marked with each letter. The picture shows three side views of the pyramid. What is the letter on the ball with the question mark? So, what is the letter on this ball? So, there are 5 letters and there are 2 balls marked with each. So, 5 times 2. So, we have total of 10 identical balls, right? So, first, this is how a triangular pyramid looks like. Right? So, it has 1, 2, and 3 side faces, and 1 is base. Okay. If you notice it carefully, right? Let's take a look at this second side face, this one, right? I can already see 2 B's, right? Then I already see the 2 B's, so this cannot be a B because we have 2 balls marked with each letter and I already see 2 B's there, all right? I also see 2 D's, right? So it also cannot be D. If I take a look at this side face, I see 2 C's, so it cannot be C, right? Finally, I see 2 E's, right? So it also cannot be E. Then the only remaining is A, right? So this ball must be A. A is the correct choice. There is another way we can solve this problem. So as you can see, there are 3 layers of balls, right? And these are the 3 side views. So let me try to draw each layer one at a time. So this is the top layer. Let me call it layer 1. This is the middle layer, layer 2, and this is the bottom layer, layer 3. All right. So these are the side views, right? So top layer has only one ball, and we know that is A. See, this is layer 1. This is the top layer. Now layer 2, actually we'll have, if you think about it, it will have 3 balls, right? Now, and they will be B, C. Let me draw it bigger. B, C, and E, right? So this is layer 2. Okay, so you can see that this is BC, BC, EB, EB, CE, CE. Okay, now layer 3 we have 6 balls, right? Okay, so this is layer 3, or this is the bottom layer. So we want DBD, DBD, ECD, ECD, and then we have D something E. So this is the question mark, right? D something E. So we need to find out what is this. Now from here also we can clearly see. Let me write down the different letters: A, B, C, D, E. And so in this layered views, I am seeing each ball only one time, right? So I can count each letter how many times they appear. A is here, I see only one time, right? There is only one time. Okay, now let's check B. B is 1, 2. So B appears 2 times. How about C? 1 time here, 1 time here. C appears 2 times. How about D? 1 time here, 1 time here. E, 1 time here, 1 time here. So it's total of 2 times, right? So the only letter that doesn't appear twice is A. I only see 1 time here. So this must be an A then, right? Same as before. A is the correct choice. Ronja had 4 white tokens and Wanja had 4 gray tokens. Okay? They played a game in which they took turns to place one of their tokens to create 2 piles. Ronja placed her token first, and Ronja had white, right? Ronja had white. Okay, which pair of the piles could they not create? All right, so let's try to trace the tokens one at a time and see which one we cannot make. So we have to start with white first, right? Need a white, and then gray. This is the only choice, and then I need a white, then I need a gray, then white, gray, white, gray. So I can make this one. Let's try B. I have to start with the white because white goes first, and gray, this is the only choice. Then I need white. I can go either here or here. Let me try going here, white, and then gray, white, gray, white, gray. So I can also make that. Here I start with white, gray, white, gray, white, gray, white, and gray. So I can also make this. Here start with white, and then gray. I can go either here or here. So let me try this one, gray. Then I need a white. Then I need a gray, white, gray, white, gray. So I can also make that. All right. So seems like this is the only one that is remaining. So this must be the correct answer. But let's try it out. I start with white. I need a gray, and then I need a white, and then I need a gray. So I can go either here or here. But after gray, I need a white. So I have to go. This is gray, then white, then gray, and then here I am stuck. I do not have a way to place a white. Then I cannot make C. Then sorry, I cannot make E. Then E is the correct choice. There is another way to think about this problem. We have white and gray tokens, and Ronja placed her first token first, right? And Ronja has white. So it will be white first, and then gray, then white, and then gray. Go on. We will end with white and then gray because they have equal number of tokens. So if we start with a white token, we must end with a gray token, right? And then if we carefully look at the different choices, E is the only choice which does not end with a gray token. They are both white on the top, right? And that is the only one, in fact, does not end with a gray token on the top. And since there is only one correct answer, then E must be the correct choice. One important note about this way of thinking. So if at least one of the stacks does not end with a gray, it is guaranteed that that is not going to be a valid placement, right? But if one of the stacks does end with a gray, it is not guaranteed that we can make that stack. Let me give an example. So I have drawn an example where I have already placed the tokens. Let's assume the shaded ones are gray tokens. So I have 1, 2, 3, and 4 gray tokens. And then I have 1, 2, 3, and 4 white tokens. Now, if I try to trace this one, if I start with a white, there is nowhere for me to go to place a gray token. So this stack is not possible with these conditions, even though one of the stacks ends with a gray token. So I want to reiterate, if at least one of the stacks does not end with a gray token, it's guaranteed that that is not a possible placement, right? But even if one of the stacks ends with a gray token, it is not guaranteed that that will be a valid placement. And this is one example. 3 pirates were asked how many coins and how many diamonds their friend Graybeard has. Each of the 3 told the truth to one question but told a lie to the other. Okay, truth to one questions and lie to other. Their answers are written on the piece of paper picture here. What is the total number of coins and diamonds that Graybeard has? Okay, if we look at the 3 statements, we see that both 2 and 3, they are saying 7 coins, right? So that must be true, because let's say if 7 is not true, then this must be true because they told one truth and one lie. So if this is not true, this must be true, right? But if this is not true, this also cannot be true because they are the same. Now, if this is not true, this has to be true, right? But 4 and 7, they cannot be true. They are different, right? They cannot have 4 diamonds and 7 diamonds. So they are different numbers, right? Then 7 coins and 7 coins. These must be true. Now, if 7 coins is true, 8 coins cannot be true. That means 6 diamond is true. right? So that means total of 7 plus 6 is equal to 13, right? And C is the correct choice. There were 20 apples and 20 pears in a box. Carl randomly took 20 pieces of fruit from the box and Luca took the rest. So they each got 20. Which of the following statements is always true? Alright, so let me make a simple table. Carl, Luca, A for apple, P for pear, A for apple, P for pear. Okay, and let me check each of these answers one at a time. Carl got at least one pear. Not necessarily. Carl could have gotten 0 pear and all 20 apples, right? So this is definitely not always true. Okay, Carl got as many apples as pear. Again, not necessarily. So again, from this example, he could have gotten 0 pear and 20 apples, right? So this is also not always true. Carl got as many pears as Luca. All right, so let me take another example here. Let's say Carl got 5 pear. So he would have gotten 15 apple because 15 plus 5 is 20 and he had picked 20 fruits. So in this case, Luca would have got, there are total 20 apples, 15 is already picked, so 5 apple, and then again there are a total of 20 pears, 5 is already picked, so 15 pears. So Carl got as many pears, right, as many pears as Luca. Not true, right? Here Carl got 5 but Luca got 15. So this is again not always true. All right, Carl got as many pears as Luca got apples. Okay, Carl got as many pears as Luca got apples. All right, so that seems like always true. Okay, so let me take a general case. Let's say Carl got n pear, then he would have got 20 minus n apples because he picked a total of 20. So if we add this together, 20 minus n plus n is 20, right? So in that case, Luca would have got how many apples? See, Carl already got 20 minus n and there are total 20 apples. So 20 minus n, because 20 minus n Carl already got and there are total of 20. So this is 20 minus 20 plus n. This negative and negative will become positive. So this is n, right? Then Luca would have got an apple. And Luca got an apple, then he would have got 20 minus n pear because he got 20 fruits in total, right? So Carl got as many pears as Luca got apples, So this is always true, right? So seems like D is the correct choice. Let's take the last one. Carl got as many apples as Luca. So Carl got as many apples as Luca. So again, from one of these examples, we can see that this is not necessarily true. Then D is the correct choice. In a railway line between cities X and Y, the trains can meet traveling in opposite directions only in one of its stretches, in which the line is double. Somewhere like this. The trains take 180 minutes to go from X to Y and 60 minutes to go from Y to X at constant speed. On this line, a train can start from X at the same instant that a train starts from Y without them colliding during the trip. Which of the following figures represent the line? All right, so we have a train going from X to Y in 180 minutes. So we can see that there are 1, 2, 3, 4, 5, and 6 equal segments from X to Y. So for each segment, 180 by 6 is 30 minutes per. So it takes 30 minutes per segment going from X to Y. Similarly, from Y coming back to X, it takes 60 minutes. Then for each segment, 60 by 6 is equal to 10 minutes per 10 minutes per segment. All right. So going from X to Y, it takes 30 minutes for each segment, and then coming back from Y to X, it takes 10 minutes for each segment. All right. Let me draw another line here from X to Y. So this is X, this is Y, and let me draw the 6 segments: 1, 2, 3, 4, 5, and 6. All right. So let me start 2 trains, one from X and one from Y. Okay. So when this train starts from here, one segment, it takes 30 minutes. We found that out, right? So when another train starts from Y, in 30 minutes, it is going to come 10 minutes, 10 minutes, 10 minutes. It takes 10 minutes per segment. So in 30 minutes, it is going to cover 3 segments, right? So 10 minutes here, 10 minutes here, 10 minutes here. Okay. All right. So this is the first 30 minutes. Next, let me change the color. In next 30 minutes, this train is going to go from here to here. This is another 30 minutes, right? Per segment, it takes 30 minutes. And at the same time, this train is going to, in 30 minutes, is going to go here, here, and here, right? So it's going to take 10, 20, 30, another 30 minutes. So as you can see, when this train is going from here to here, this train is going to cross it somewhere, right? So they are going to cross each other. So when this train is here, let me change the color again. When this train is here, this train is here. But when this train has arrived here, this train would have arrived here. So somewhere in between this, somewhere in this segment, they are going to cross, right? So this is the segment where there needs to be a fork, or the line needs to double, right? So this is the segment. This is the second segment. That is, then B is the correct answer. Ann, Bob, Carina, Dan, and Ed are sitting at a round table. All right. Ann is not next to Bob. All right. Let me write down the names. They are conveniently named A, B, C, D, and E. So I'll write A, B, C, D, E. Ann is not next to Bob. And it is not next to Bob. Okay. So I'll put a cross. Dan is next to Ed. Okay, Dan and Ed are next to each other. And Bob is not next to Dan. Okay, Bob is not next to Dan. Okay, which two people are sitting next to Carina? Okay, which two people are sitting next to Carina? All right, so let me draw a round table. I know that D and E are together, so let me first place them. D and E, so they are next to each other, so there are 3 more spots: 1, 2, and 3. Okay, Dan and Ed, they are sitting next to each other, so I place them on the table first, and then there are 3 more spots left. Okay, now B and D are not next to each other, so B cannot be here, right? B cannot be next to D, so B can be here or here, right? So that is this condition. Oops. So that is this condition. Now A is not next to B. Okay, if I put B here, no matter whether I place A here or here, A is going to be next to B. Therefore, B cannot be here. B has to be there so that A can be here, right? So that A is not next to B. Then who is left? C is left, right? Then C must go here, all right? Then which two people are sitting next to C? A and B. So that would be, the correct choice is A. Maurice asked the canteen chef for the recipe of his pancakes. Maurice has 6 eggs, right? 6 eggs, 400-gram flour, 0.5 liter of milk, and 200-gram butter. What is the largest number of pancakes he can make using this recipe? What is the largest number of pancakes he can make? All right, so this is the recipe. For 100 pancakes, I need 25 eggs, 5 kg of flour, 4 liter of milk, 1 kg of butter. Okay, so let me first calculate for one pancake how much of the ingredients I need. So for one pancake, okay, I need, for 100 I need 25 eggs, then I will need 25 by 100 is equal to 1/4 egg, right? So for 100 pancakes I need 25 eggs, so for one pancake I will need 25 by 100, which is 1/4 egg. Okay, how much milk I need? So 4 liter for 100 pancake. For one pancake, 4 over 100 is equal to 1 over 25 liter milk. Okay, for the flour, for 100 pancake I need 5 kg. For one pancake I will need 5 over 100, but flour is given in gram here, so let me convert the kg. So this is in kg, so 5 kg is 5,000 gram, right? So this is going to be 50 gram of flour. Okay, and then what is remaining? Butter. Butter is also given in gram, so I'll convert it to gram. So I need 1000 gram butter, which is 1 kg for 100 pancake. So for one I need 1000 by 100 is equal to 10 gram of butter. All right, all right. So for one pancake, these are the ingredients I need: 1/4 egg, 1/25 milk, 500 gram flour, and 10 gram of butter. Okay, so with the ingredients that I have, let me see how many pancakes I can make. So let me start with egg. I have 6 eggs, right? So I have 6 eggs. I need 1/4 of an egg for one pancake, right? So with 6, I can make 6 divided by 1/4 pancake, right? So this is going to be 6 times 4 is equal to 24 pancakes, right? So with the egg, I could make 24 pancakes. With the milk, how much milk I have? 0.5 liters of milk, right? But for one pancake, I need 1/25 liter. So 0.5 divided by 1 over 25. So 0.5 is basically 5 over 10, and then this one will flip up. So this is 25. So this is going to be 12.5. But I cannot make half a pancake, right? So this will be 12. So 12 pancake. With just the milk, I can make 12 pancake. Okay. Next is flour. How much I have? 400 gram. I have 400 gram, but for one, I need 50 gram, right? So this is going to be 8, right? So with just the flour, I can make 8 pancake. Okay, and then what is remaining is the butter. How much butter I have? I have 200-gram butter, but for one I need 10-gram butter. So divide by 10. So this is going to be 20. All right. Now let's try to understand these different numbers: 24, 12, 8, and 20. With the amount of egg I have, I can make 24 pancakes. But to make 24 pancakes, I do not have enough milk. With the amount of milk I have, I can make only 12, right? Then what is going to limit the number of pancakes I can make? It is going to be this number, right? Or the flour. Because with the amount of flour I have, I can make only 8 pancakes. If I want to make more than that, I don't have enough flour. So although with egg, milk, and butter, I could make more pancakes than 8, I just don't have enough flour. So that is going to limit the number of pancakes I can make. Then 8 is the correct answer, and B is the correct choice. The picture shows 3 gears with a black gear tooth on each. Which picture shows the correct position of the black teeth after the small gear has turned a full turn clockwise? Okay, so it's going to, the small gear, there's the pink one, going to turn one full turn clockwise. So let's count the number of teeth the small black gear has. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it has 10 teeth, right? So when it turns one full round, the black tooth of the smallest gear is going to come back to that position, and it would have traveled 10 teeth distance, right? So when the black is turning this way, as you can see, the black is touching the purple. So if the black is turning this way, the purple is going to turn this way. And when it goes one round, it is also going to travel 10 teeth distance, right? So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where the black teeth will be after it has turned one round. All right. Now, when it is turning this way, the purple is touching the blue, right? So the blue is going to turn this way, right? Then the black tooth is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is going to be somewhere here, right? Now, as you can see, this matches to this one, right? Then A is the correct choice. An apple and orange weigh as much as pear and peach. Okay, let me write it down. A for apple plus O for orange weigh as much as pear, I write it as PR, plus PH as peach. And apple and pear, apple plus pear, less than orange and peach, less than orange plus peach. Okay, and a pear and orange, less than apple and peach. Okay, which of the pieces of the fruit is the heaviest? So we want to find out which fruit is the heaviest. From here you can kind of see that wherever there is peach, that side is heavier, that side is greater, right? So somehow it feels that peach is going to be the heaviest, right? But let's try to prove it in a more formal way. Let me call this equation 1, equation 2, and equation 3. Okay, let me change the color. Let me do equation 1 plus equation 2. Okay, I'm going to write down equation 2 as it is first, and then I add the equation 1 to that. So A plus PR is less than O plus pH. Again, I have written down equation 2 as it is, and then I'm going to add equation 1 to that. So equation 1, A plus O is equal to PR plus pH. So if I add the equal amount to both sides, the inequality will still hold, right? For example, let's say 3 is less than 7, and if I add equal amount to both sides, say plus 2 and plus 2, so this is going to be 5, this is going to be 9. Again, the 9 is still greater than 5, right? The inequality will still hold. Okay, so what I'm going to do is add the equal amount to both sides. So A plus O here, A plus O, and this side PR plus pH, right? So I'm adding A plus O to the left hand side and pear and peach to the right hand side. Once I do that, as you can see, I can take out orange from both sides, which is fine. The inequality will still hold. I can also take pear from both sides, right? Now what is remaining? This is 2A, 2 apples less than 2 pH, right? And if I divide both sides by 2, this tells me A less than pH. So this is 1, right? Next, let me do 1 plus 3. I'll do it the same way. I'll first write down equation 3. So that is PR plus O less than A plus pH, and then I'll add equal amount to both sides from equation 1. So that is A plus O and PR plus pH. So I started with equation 3, the inequality, and then adding same amount, equal amount to both sides from equation 1. And here also you can see I can cancel out A, I can take out apple from both sides, and then I can take out pear from both sides. So this leaves me 2O. This is O for orange. This is not 20. Okay, let me put some symbol there. Is less than 2 pH, right? So I can divide both sides by 2. So this tells me orange is less than peach. Okay, that's the second one we got. Now finally, let me do 2 plus 3. 2 plus 3, equation 2 plus equation 3. So I can write down equation 2 first. A plus PR is less than O plus pH. All right. So this is equation 2. I have kept the inequality. Now, if I'm going to add the lesser side to the lesser side and heavier side to the heavier side, then the inequality is going to still maintain, right? For example, say 3 less than 5, and then 1 is less than 2. So if I add these two together, so this is going to be 4, this is going to be 7, the inequality is still going to hold, right? If I'm adding the lesser side to the lesser side, heavier side to the heavier side, the inequality is going to maintain. So what I'm going to do here is I'm going to add the lesser side to the lesser side, PR plus O, and then heavier side to the heavier side. So A plus pH. A plus pH. Okay. As you can see, I can take out orange from both sides. I can take out apple from both sides. So this tells me 2 PR is less than 2 pH, and then divide both sides by 2. This tells me PR less than pH. Okay. So as you can see now, peach is heavier than pear, peach is heavier than orange, peach is heavier than apple. Then peach is indeed the heaviest fruit. What is the smallest number of shaded squares that can be added to the diagram to create a design including the grid with 4 axes of symmetry? Alright, so what are the axes of symmetry of a square? This is one axis, the second one. This is the third axis of symmetry, and this is the fourth axis of symmetry, right? So these are the four axes of symmetry of a cube. All right, so let me start with one axis of symmetry, this one. So to make this as an axis of symmetry, I can see that I need to add one here, and one here, right? All right, next. If I want to make this as an axis of symmetry, I need to add here, 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 and here, here, and here, right? Okay, next. If I want to make this as an axis of symmetry, where do I need to add the shading? I can see that, okay, let's start with here, this, and this. And with respect to this, it will be this, and this. Okay, so that covers this side. With this side, I will have a similar, it will be this, and this. For this one, I need to have this, and this, right? Okay, now this covers the third axis. How about the fourth axis? What the fourth axis of symmetry? In this case, I can see that, this axis is already covered. This, it is already symmetric with respect to this axis. So how many extra shaded squares I have added? So here there is 3, and there is 1, 2, 3, 4, 5, 6, 7 of those sections, right? So 7 times 3 is, I have added 21 more shaded squares, right? Then E is the correct choice. There is another little bit less cumbersome way to think about this. Let me, just mark where this pattern is there, right? Now, if I want to make this as an axis of symmetry, that pattern has to be here, okay? And then if I want to make this as an axis of symmetry, this pattern needs to go here and here. Similarly, if I want to make this as an axis of symmetry, this pattern needs to be here, and this pattern needs to be here, okay? And similarly, this pattern needs to come here, and this pattern needs to come here, okay? Now that covers this 3 axis of symmetry. Now if I want this also as an axis of symmetry, as you can see, this is already covered. Now how many extra patterns I'm adding? 1, 2, 3, 4, 5, 6, and 7, right? And each pattern has 3 of this shaded square, right? So 7 times 3 is 21. We arrive at the same answer. My little brother has a 4-digit bike lock with the digits 0 to 9 on each part of the lock as shown. All right, like this. He started on the correct combination and turned each part the same amount in the same direction. And now the lock shows combination 6348. 6348. Okay. Which of the following cannot be the correct combination of my brother's lock? All right, so the numbers go from 0 to 9, then again 0. So let me write that down. It will be useful. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0 again, like that, right? So basically, we can check each of the choice one at a time. So let's start with 8, 5, 6, 0. If we compare with the original combination, basically, can I go from here to here by turning the same amount? So to go from here to here, how about minus 2? So 8 minus 2 is 6, 5 minus 2 is 3, 6 minus 2 is 4, 0 minus 2. All right, so that is where we need this diagram. Minus means I'm coming this way, right? So minus 1 is 9, minus 2 is 8. So yes, I can get combination A. So this cannot be the correct answer. Let's check B now. Can we go from B to the original combination by turning each a fixed amount? How about 3 to 6 is plus 3. So let me try that. So 3 plus 3 is 6, 0 plus 3 is 3, 1 plus 3 is 4, 5 plus 3 is 8. So again, B also cannot be the correct choice. All right, now let's check C. How do I go from here to here? How about plus 2? 4 plus 2 is 6, 9 plus 2, so 9 plus 2 is going to be 1, but this is a 3. All right, so seems like this is not going to work. So seems like this is the correct choice, but let's check the other ones. 1893, 1, then it is plus 5, right? 1 from 1 to 6 is plus 5. 8 plus 5, 8, 1, 2, 3, 4, 5. We end at 3, which is fine. 9 plus 5, 1, 2, 3, 4, 5. It is 4, correct. 3 plus 5 is 8. So this cannot be the correct answer. How about E? From 0 to 6 is plus 6. 7 plus 6 is 1, 2, 3, 4, 5, 6. We end up at 3, which is good. 8 plus 6, 1, 2, 3, 4, 5, 6. We end up at 4. And 2 plus 6 is 8. Then E also I'm able to get from the original combination. So seems like C is the only combination that I cannot get from the original combination by turning a fixed amount, right? Then C is the correct choice. So for every problem, I typically try to solve it myself before recording the video. So a few days back when I was trying to solve this problem, my son happened to see me solving. And he said, this seems like an easy problem. I was like, do you want to solve it? He said, sure. So he stared at the problem for 20-30 seconds. Then I asked him, do you need some pen and paper? He said, no, correct answer is C. I said, how? He said, you see, there are black numbers and there are also gray numbers written on the dial, right? So if you see here, there is 0782 matches with 0782 here, okay? And then this 2904 matches with this 2904, okay? And here this 9671 matches with this 9671. So this is the only odd one out, right? Then this must be the correct choice. And he was right. So sometimes kids come up with this lazy way of solving a problem that turns out to be really smart. And I was like, why didn't I think of that? Each shelf holds a total of 64 deciliters of apple juice. The bottles have 3 different sizes, large, medium, and small. How many deciliter of apple juice does a medium bottle contain? All right. So if we use algebra, this problem becomes really easy. Let me show how. So let me write the equation for this. There are 3 large, 3L, 1, 2, 3, 4 plus 4 small, and this is equal to 64. So for large, I'm denoting as L. For small, I'm denoting as small. And for medium, I'll denote it as M. So this one then is 3 small plus 2 large plus 2 medium is same 64 because each shell contains a total of 64 deciliters. Now this one is 1, 2, 3, 4, 5, 6. 6 small plus 1, 2, 3, 4. 4 medium is equal to 64. So let me call this equation 1. This is equation 2. This is equation 3. So if we see carefully, if I can somehow eliminate medium from these two equations, right, I'll be left with small and large, and then I have this equation that has only small and large. Okay, so let me multiply this equation by 2. So this is equation 2 times 2. This will lead to me 6s plus 4l plus 4m equal to 64 times 2. And then I'll write down equation 3. 6s plus 4m is equal to 64. So what I'm going to do is subtract this equation from here. So put a minus here. So if I subtract it, 4m is going to go out. In fact, the 6s is also going out. So that means 4l is equal to 64 times 2 minus 64. So that is just 64. And this straight away gives me L is equal to 16. All right. So that was nice. So if L is 16, right, from equation 1, this implies 4s is equal to, so 3 times 16 is 48. So 64 minus 48. This is going to be 16. Then S is going to be 16 by 4 is 4. Okay. Now I know the large, I know the small. I can just use this equation. Okay, I just need the small here. 6 from equation 3. 6 s is 4. 6 times 4 plus 4 m is 64, right? So this is 24. So 4m is equal to 64 minus 24. So 4m is equal to, this is 40, right? Then m is 10, right? Divide both sides by 4. Okay. Then, and we want the medium bottle. Then D is the correct choice. M is 10. A large cube has a side length 7 cm. On each of its 6 faces, 2 diagonals are drawn in red. The large cube is then cut into small cubes with side length 1 cm. How many small cubes will have at least one red line drawn on it? So let me draw the cube. Okay. Now this is going to be cut into smaller cubes of 1 cm side length. So let me draw that grid. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Similarly here, 1, 2, 3, 4, 5, 6, and 7. Okay. Then let me draw the red diagonals. If I draw the lines to scale, the diagonal has to go through these corners, right? The diagonal has to go through that, right? Similarly, this diagonal has to go through this, right? Okay. Now, after I cut this into the smaller cubes, right? If I just look at this face, I have 1, 2, 3, 4, 5, 6, 7 for this diagonal, and 7 more for this diagonal, but I'm double counting this. So that is 7 times 2 minus 1, right? So there is 7 this way, there is 7 this way, but I'm double counting this, so minus 1. So this is 13. 13 on one face. But I have 6 faces because the red line are drawn on all 6 faces, right? These are 3 and the 3 that we are not able to see, right? So times 6, this will be 78. However, notice that I'm double counting, in fact, triple counting the corner cubes. So this corner cube here, right? I should count only one time, right? Because this is the same cube, right? There are 3 lines on it, but it's the same cube. So I'm counting it once, twice more than I should, right? So this should count as 1, but this counted as 3 times. So I have to subtract 2 times from here. And similarly, there are 8 of these. 1, 2, 3, 4, 5, 6, 7, and 1 on the behind that we are not able to see. There are 8 corners, right? And I have to subtract 2 from each. So that is 16 minus 16. So this will be 62. So I'll end up with 62 cubes that have at least one red line on it, right? And the correct choice is B. In a group of 10 elves and trolls, each were given a token with different numbers from 1 to 10 written upon it. They were each asked what number was on their token and all answered with a number from 1 to 10. The sum of the answers was 36. Each troll told a lie and each elf told the truth. What is the smallest number of trolls there could be in the group? All right, so the numbers were from 1 to 10, right? 1, 2, 3, 10. Now, if everybody told the truth, the sum would be the sum of consecutive numbers from 1 to 10, and that is the last number times the last number plus 1, which is 11, divided by 2. So this is the formula, right? The sum of numbers from 1 to n is n times n plus 1 divided by 2. So this would be 55. So if everyone told the truth, the sum would have been 55. But the sum we are getting is 36. So 55 minus 36 is 19. So we are getting 19 less than we should get, right? Okay, now we know that a troll is telling a lie. So what is the minimum number of troll that has to be there? So what is the maximum lie a troll can tell? The maximum lie a troll can tell is he gets a 10, but he tells I got 1, right? That is the maximum number. He gets the biggest number, but he tells the smallest number, right? Okay, so that would be a lie of 9. That is with one troll who tells the maximum lie. Let's take a second troll. Now, if the first troll got a 10, the second troll could not have gotten a 10. That would be a number less than that, right? But still we want to see what is the next maximum a troll can say, right? So he would have gotten, let's say, 9, and then he said I got 1, right? So that is the next maximum a troll can say. So that would be 9 minus 1 is 8. So we have total of 17 right now, right? 17 less than we should have, but we need 19. So we need one more troll. In fact, if the next troll says, 1, but he in fact got 3, right? Then that would be a lie of 2, right? He would be understating it by 2, right? So this plus 2 is 19, right? So as you can see, we need a minimum of 3 trolls, right? 1, 2, 3 trolls. So we need a minimum of 3 trolls to lie so that we get the sum 19 less than we should, right? So then correct choice is B. One thing to note here is that each token has a different number. So the trolls cannot be getting the same number, right? So these numbers have to be different. But they all can say that they got 1. Nothing is stopping them from saying that they got 1, right? So they can lie, right? But they cannot be getting the same number. That's why I have taken different numbers, and I have done in a way to maximize the lie so that I can minimize the number of trolls. There are rectangular cards divided into 4 equal cells with different shapes. So these are the shapes drawn in each cell. Cards can be placed side by side only if the same shapes appear in adjacent cells on their common side. Okay, same shapes appear in adjacent cells on their common side. 9 cards are used to form a rectangle as shown in the figure. So this is 3 card by 3 card. There is 9 cards. Which of the following cards was definitely not used to form this rectangle? I thought this problem was a bit tricky, and it has to do with the language. Same shapes appear in adjacent cells on their common side. So initially I thought a triangle has to go next to a triangle and a square has to go next to a square. But that is not true. That is not necessary, right? All it says is same shapes appear in adjacent cells on their common side, right? So this is a common side. Same shapes has to appear on the adjacent cells. So it can be a triangle and a square, or a square and a triangle. So these two cells, it can be a triangle and a square like that, or a square and a triangle like that, right? Both are valid. Okay, now if that is the case, which of the cards allow this configuration? We can see that square and triangle, so this one, and square and triangle, this one. So these 2 cards can be then used, right? So these are not valid choices then, right? Because we want to find the one that is definitely not used to form the rectangle, right? Now let's talk about the cards that we have to arrange vertically. So let's take this one. So here, this is another common side, and these 2 cells have to be filled by a star and a square, right? A star and a square, or similarly a square and a star. So either this or this, both will be valid, right? Now if I look at that, I can see that star and square has to be horizontally stacked. So this is horizontally stacked, and star and square, they are horizontally stacked. Star and square, they are vertically, they are not horizontally stacked here. So again, A and C can be used to form this rectangle, right? So then the only one that is left is E. So then E must be correct choice. Again, if we take these configurations, triangle and a square, they have to be vertically stacked in the cards that we can use. And here, triangle and a square, they are diagonal, right? In this case, star and a square have to be horizontally stacked. Star and a square, they are not horizontally stacked, they are vertically stacked. So this card cannot be used to fill the rectangle horizontally or vertically, right? Then again, E is the correct choice.